Good morning. Today we are talking about polygon similarity. We've talked about some congruency. Now we're going to talk about some similarity. So two polygons are similar if their corresponding parts, as in their angles, are congruent and their sides are proportional. So the angles are going to be the same measurement and the sides are going to have a similar ratio or fraction to each other. Remember the symbol for similarity, or if you didn't know, the symbol for similarity is this little tilde symbol. Polygons that are similar are going to have the same shape but not the same size. So it might be a square that is smaller and then a larger square. Okay. If polygons are similar, they have a scale factor, which is the ratio between the two figures' corresponding sides. So we need to figure out what sides are in the same spot, and we're going to compare them. Scale factor is always written as the smaller over the larger as a fraction, or it might be written as a smaller and these little colon larger. So that's if it's written as a statement. Notice this example right here. It says 2/3 is the same thing as 2 to 3. All right, so for these couple examples, we're going to assume that the polygons are similar, and then we're going to find whatever is asked. Okay. The first thing we need to figure out in polygon similarity is which sides are in the same spot. So 35 and 42 are in the same spot. The question mark and 30 are in the same spot. This bottom side are in the same spot. And of course, that leaves these two in the same spot. So if I were to compare any of them, they should all have the same ratio. 35 over 42, the pink question mark over 30, the smaller blue over the smaller or larger blue, they should all have the same ratio. When we are finding missing sides, we're going to compare the sides. We don't have to necessarily find the scale factor. Okay, we need to make sure we stick to we're going to stick with doing the smaller over the larger so that we get in good habit for finding the scale factor. Okay, so 35 and 42 is going to have to be the same ratio as my question mark over 30. Okay, because they're in the same spots. If I simplify these, they should have the same fraction. Remember, we have a fraction equal to a fraction. We're going to cross multiply. 35 times 30 is 1050. 42 times question mark. Okay. To solve for the question mark, I'm going to divide both sides by 42. If it makes you feel better, don't use a question mark. Use X or Y or whatever letter you want to, so you know what you're solving for. It's 25. Okay. If I compare these, I should get the same ratio. 35 over 42. If I simplify that, is 5 over 7, or 5 over 6, I'm sorry. And then if I compare 25 over 30, it's also 5 over 6. So same ratio. All right, same thing for B. I'm going to compare the sides that are in the same spot. This one's a little trickier because it did kind of rotate around. Pay attention to the shape and the angles, okay, so that you can see which ones are in the same spot. I'm going to compare them. So I know I have to do the 3 and the question mark. The 3 is a smaller one. And then it doesn't matter if I do the 6 over 36 or the 5 over 30, they simplify to the same thing. So I'm going to do 6 over 36. And then I'm going to cross multiply. 3 over 36 is 108. 6 times question mark. I'm going to divide both sides by 6. And my question mark equals 18. Okay. Again, if I compare, 6 over 36 is 1/6. 3 over 18 is also 1/6. C, find the value of x. 18 and 15 in the same spot. 5x minus 3 and 35. 21 and this unknown side. And last but not least, this unknown side and the 25. Okay, So I need to figure out which sides to compare. I'm going to again pick the smaller one. I need to solve for x, so I definitely have to use this side and this side. 35 is my smaller, because it's my smaller figure. And then I'm going to set it equal to, the only one that has both pieces is the 18 and the 15, so I need to use those to compare. Okay, I am going to cross multiply now. 35 and 18 is 630. 15 times 5x minus 3, so 15 times 5x is 75x. 15 times negative 3 is negative 45. Add 45 to both sides. 675. Then divide both sides by 75. And x equals 9. All it asked me to do was to find x. If I want to, I can plug it back in and figure out what the side length is of that trapezoid, and then I can compare and make sure that the ratios are still the same. Okay. Same idea with D. You plug it in. The worksheet with the key is posted. If you do it, you get x equals 7. But it asks me to find the missing length. 2 times 7 is 14, plus 6 is 20. Okay. Try to work it out and see if you can figure it out and get those correct answers. Okay. All right. Now we're going to determine the scale figure, or determine if they are similar, and determine the scale figure. Okay. So I need to figure out which sides compare. 15 and 10 go together. This happens to be rectangles, so we can look at both those. And then the 21s are going to go with 14. In order for them to be similar, both ratios have to be the same. So smaller over larger. So 10 over 15, if I compare those two. If I figure out what that fraction is, it's 2 over 3. If you're not comfortable with simplifying fractions, remember you can go to Desmos, and Desmos will do fractions for you. That snowman looking on the side I have. I'll show you in a minute. Okay. And then the other one, 14 over 21. To simplify equals 2/3. So comparing them, I get 2/3 for both. Because they are the same, they are similar, and my scale factor is 2/3. Okay. I'm going to compare these two right here. So these parallelograms have 24 and 30 in the same spot, and they also have 40 and 28 in the same spot. So in order to determine if they are similar, I'm going to compare smaller and larger. So 24 over 30. If I simplify that, I get 4/5. 28 over 40 simplifies to 7/10. Notice that these two ratios now are not the same. Because they are not the same, they are not similar. Means it was stretched more one way and not the other. Okay. Same idea here for C. Okay. Determine which one's smaller, larger. Okay. Compare sides. 24 and 18 in the same spot. 12 and 9. Okay. So I'm going to do my smaller over my larger. And then my smaller over my larger. Oops. This time, my ratios are the same. Since they're the same, my figures are similar, and my scale factor is 3/4. Okay. All right, on to the back. All right, dilation. So remember we talked about transformations, rotations, reflections, and translations. Sorry, I went blank there for a minute. This one is dilations. We did not talk about this one at the same time because this time it is not rigid motion. it does change size. Okay, so dilation is a type of geometric transformation that uses a scale factor to make a copy of the figure larger or smaller. Okay, so remember, if you think about going to the eye doctor, if they dilate your eyes, your pupils get really, really big. Okay, but also remember that dilation can be smaller. It can be the same shape, just different size. In order to do this, all we're going to do is we're going to find our dilation and we're going to multiply each of our ordered pairs by that number. Straightforward. Okay, A. A originally is at -2, 2. If I come over here to my problem, notice they use D for dilation and then a 2 means all I'm going to do is I'm going to multiply each one of my ordered pairs by 2. So A prime, -2 times 2 is -4. 2 times 2 is 4. So -4, 4, A prime. Remember that prime tells me that it was moved. Okay. B originally is at 1, 1. We're using the same scale factor, so we're going to multiply it by 2. 1 times 2 is 2. 1 times 2 is 2. So my new B value is at 2, 2. All right. And then C is at 0, -3. Going to multiply these by 0, or by 2, sorry. 0 times 2 is still 0. -3 times 2 is -6. If I connect my pieces, you will notice that my figure got larger. Yeah, and that's my new one. All right, if you had to guess, since this dilation this time is 1/2, guess what it's going to do? It's going to get smaller. Okay, so I'm going to do all my order pairs. A is at 2, 4. I'm going to multiply each one by 1/2. 2 times 1/2 is 1. 4 times 1/2 is 2. B is at -4, 0. I'm going to multiply each one of those by 2, or multiply both of those by 1/2, sorry. -4 times 1/2 is -2. 0 times 1/2 is still 0. And last but not least, C is at 1, -4. I'm going to multiply each one of those by 1/2. 1 times 1/2 is 1/2. -4 times 1/2 is -2. And as I said, you'll notice that the figure got smaller. It is still the same shape, just smaller. You'll also notice that the new sides are parallel with the old sides. Okay. All right. There's a worksheet attached that you will need to complete and take a picture of when you are done. There are a few pictures, graphs like these ones that need to be done. What you can do is you can just tell me the new ordered pairs for them. All right.